Hi friends, in this session we'll start with the P block elements. So in P block element, group number 13 to group number 18 are available. So in your syllabus, group 13 and 14 is there. 15, 16, 17 and 18 are available in 12 standard. So in short, within this 2 years span, you have to discuss full P block elements. But rest assured, tension मत कीजिए. इस साल हमें only and only group 13 and 14 पढ़ना है. Group 13 is all about boron family. Group 14 is all about your carbon family. So let's start with P block elements. So what actually means by P block elements? These are the elements in which the last electron enters into this outermost shell, that is called as P subshell. So P subshell can accommodate 6 electrons, and due to this total 6 group are available. They include elements of group 13 to 18. So basically, just because P can accommodate 6 electrons, so P1 to P6 means group 13 to group 18. The general outermost electronic configuration is NS2 NP126, and P1 stands for 13 and NS2 and P6 stands for group 18, except for helium. They include metals, non-metals and metalloids. P block के अंदर सारे के सारी varieties आपको देखने को मिलेगी, metal, non-metal and metalloids. Group 13 of this long form of this periodic table includes which are the family member of group 13, that is boron, aluminium, gallium, indium, thallium. Boron is the first member of this group 13 and the periodic table is only non-metal of this group. Obviously topmost family member जितने भी है वो सारे के सारे non-metal है. जैसे जैसे नीचे चले जाओगे ग्रुप के अंदर metallic characteristics increases. The all other members are metals. The non-metallic nature of boron is due to the smaller size and high ionization enthalpy. Once again, जैसे S block के अंदर हमने पढ़ा था anomalous behavior and diagonal relationship. Likewise, anomalous behavior किसकी वजह से होता है? Just because smaller in size and high ionization enthalpy. The members of this family are collectively known as boron family, and sometimes it is also known as aluminium family. So this is all about your group number 13 introduction or as well as P block elements. So without wasting much time, we'll move on to this group number 13. पहले group number 13 boron family followed by aluminium, दोनों का दोनों in detail discussion करने वाले हैं. And then उसके बाद group number 14 means carbon and silicon family के बारे में discussion करेंगे. So let's start with the group number 13 boron family. Group number 13 includes boron, aluminium, gallium, indium, thallium and neodymium. Among these elements, boron is a typical non-metal and another remaining family member are metallic in nature. Boron is fairly rare element, mainly occur into this orthoboric acid, that is H3BO3, borax, that is Na2B4O7.10H2O, and kernite, that is Na2B4O7.4H2O. In India, now we moved on to these occurrences. कहाँ पे ये सारी चीज कहाँ पे मिलती है? Highest concentration और rich कहाँ पे है? तो in India, borax occur in a Puga Valley. Puga Valley कहाँ पे है? Ladakh. Sambar Lake in Rajasthan. The abundance of boron in earth crust is less than 0.0001% by mass. There are two isotopic form of boron, that is B10 and B11. B10 is available in 19% and B11 is available in 81%. After boron, aluminium is the most abundant metal and the third most abundant element in the earth crust by 8.3% by mass. After oxygen 45.5% and silicon 27.7%. अब aluminium मिलता कहाँ से? किसमें? So ores, bauxite. Bauxite is a rich ore, Al2O3.2H2O and cryolite, that is Na3AlF6 are important minerals of aluminium. In India, it is found as mica in Madhya Pradesh कर्नाटका, उड़ीसा, जम्मू. गैलियम, इंडियम एंड थैलियम आर लेस अबंडेंस एलिमेंट इन नेचर. तो ये फर्स्ट पैराग्राफ जो ग्रुप नंबर 13 के अंदर था, उसके अंदर हमने अकरेंसेस के बारे में पढ़ा, कहां से बोरॉन एंड एल्यूमिनियम मिल रहा है. नाउ नेक्स्ट वी मूव ऑन टू दिस इलेक्ट्रॉनिक कन्फिगुरेशन. नाउ इलेक्ट्रॉनिक कन्फिगुरेशन क्या होगा? दैट इज ns2np1. सो the outermost electronic configuration of this element is ns2np1. A close look at the electronic configuration. So यहाँ पे आप देखिए electronic configuration सारे element का दिया हुआ है. Fine. So boron, aluminium, gallium, indium, thallium. Helium core 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1 and 6s2 6p1. In short, general electronic configuration क्या हो जाएगा? ns2np1. So a close look at the electronic configuration suggests that while the boron and aluminium have the noble gas core and gallium, indium have noble gas plus d10 configurations are there. Fine. तो इन दोनों में क्या होगा? गैलियम एंड इंडियम में d10 आएगा, then 4s and then 4p. बट इन केस ऑफ टेलुरियम, टेलुरियम के अंदर क्या होगा? 4f 14 भी आएगा, then d, then 6s and 6p1 is there. And in thallium has noble gas plus 14. टेलियम के अंदर क्या होगा? 14 के F, D के 10 and then you get 6s2 6p1. Thus the electronic structure of these elements are more complex than to this first group. First group and second group के अंदर there is no interventions of D block and F block. Straight away direct आपने ns1 ns2 के रूप में लिखा था. Here in case ऊपर के दो एलिमेंट के अंदर D नहीं आएगा, D इंट्रोड्यूस होगा थर्ड एंड फोर्थ एलिमेंट में 3D एंड 4D एंड फिफ्थ एलिमेंट के अंदर 4f भी आ जाएगा एंड 5D इज ऑल्सो देयर. सो दिस डिफरेंस इन इलेक्ट्रॉनिक कन्फिगुरेशन अफेक्ट the other property and consequently the chemistry of all the elements. मीन्स यहाँ पे आप स्ट्रेट अवे नहीं बोल सकते हो कि डाउन टू द ग्रुप ऐसा होगा. कुछ चीज चेंज होती जाएगी जस्ट बिकॉज D10 एंड 4D10 इज देयर. अब D10 होगा उसके बाद ns2 and np1 आएगा, तो ऑब्वियसली देयर इज अ लिटिल बिट चेंज इन फिजिकल एंड केमिकल प्रॉपर्टीज. तो हम फिजिकल एंड केमिकल प्रॉपर्टीज पढ़ेंगे, उसके अंदर ये फिर से डिस्कशन करेंगे. परफेक्ट. तो सबसे पहला पॉइंट एटॉमिक रेडियस. यहां पे भी देखिएगा थोड़ा सा चेंज होगा. डाउन टू द ग्रुप एटॉमिक रेडियस इज इंक्रीजेस बट एटॉमिक रेडियस ऑफ गैलियम इज लेस देन दैट ऑफ एल्यूमिनियम. सो एक्सेप्शनल केस स्टार्ट हुआ. फर्स्ट एटॉमिक रेडियस ऑफ गैलियम इज लेस देन टू दिस एल्यूमिनियम ड्यू टू द प्रेजेंस ऑफ कंप्लीटली d ऑर्बिटल. वाई देखिए, गैलियम इज आर्गन कोर 3d10 4s2 4p1 and due to this reason atomic radius of gallium is less than that of aluminium. So the presence of 10d electron offer only poor shielding effect for the outer electrons from the increased nuclear charge. Perfect. Next होगा ionization enthalpy. What actually means by ionization enthalpy? Minimum energy required to remove one electron from outermost shell is known as ionization enthalpy. The ionization enthalpy value, as expected from these general trends, do not decrease smoothly down to the group. Why? Once again, interventions of D and intervention of F, 3D, 4D as well as 4F की वजह से ये चेंज होगा. देखिए, the decrease from boron to aluminium is associated with increase in size. The observed discontinuity means ये down to the group same नहीं होगा. नीचे जाते हुए क्या हो रहा है? The ionization enthalpy values between aluminium and gallium and the between indium and thallium are due to this most important line. Please mark कर लीजिएगा. Inability of D and F electrons. Just because of interventions of D and F, this trend does not give continuous flow. Means ऐसा नहीं है कि बोरोन से लेके थैलियम तक सेम मोनोटोनस इंक्रीज या डिक्रीज होगा. There is a change. Why? Because interventions of D and F block elements or electrons. So, in indium and thallium are due to the inability of D and F electron, which have low screening effect to compensate the increase in a nuclear charge. So, this is all about your ionization enthalpy. Next is oxidation state and electron negativity. So next is oxidation state. Now what actually means by oxidation state? Oxidation state is nothing but number of electron in outermost shell or 8 minus number of electron available in outermost shell. So यहाँ पे दोस्तों जनरल इलेक्ट्रॉनिक कन्फिगरेशन क्या डिस्कस किया? NS2 and P1. तो बेसिकली आउटरमोस्ट शेल के अंदर कितने इलेक्ट्रॉन हुए? 3. So group 13 has general tendency, oxidation state क्या हो जाएगा? +3. Fine. But down to the group +3 की जगह पे NS2 and NP1, तो खाली P1 भी निकल सकता है. So there are two oxidation state, +3 and +1. Down to the group +3 से +1 tendency increase होती जाएगी. Why? Just because inert pair effect. इनर्ट पेयर इफेक्ट का मतलब क्या था? एस ब्लॉक के अंदर भी पढ़ाया था. इनर NS2 इलेक्ट्रॉन कैन नॉट रिमूव इजीली डाउन टू द ग्रुप. दिस इज कॉल्ड इनर्ट पेयर इफेक्ट. सो लेट्स स्टार्ट विद ऑक्सीडेशन स्टेट. द कॉमन ऑक्सीडेशन स्टेट ऑफ ग्रुप 13 एलिमेंट इज +3. ड्यू टू द हाई आयोनाइजेशन एंथैल्पी, boron does not form +3 ions and it only forms covalent compound. The stability of +3 oxidation state decreases and that of this +1 oxidation state is increases down to the group. Just now we discussed, that is called inert pair effect. Next line में वही discuss किया है. This is due to the inert pair effect. The trivalent compound formed by group 13 elements are called electron deficient compound. In this compound, the number of electrons around the central atom or molecule is only 6. Means यहाँ पे octet complete नहीं होगा. In order to attain stable octet configuration, they accept a pair of electrons, so they behave Lewis acid. Example: BF3, BCl3, AlCl3, B2H6. So last 3 लाइन बहुत ही important है. डाउन टू द ग्रुप +3 से +1 होगा. क्यों होगा? जस्ट बिकॉज ऑफ इनर्ट पेयर इफेक्ट. दूसरा यहाँ पे बताया हुआ है कि जनरली दे डोंट हैव सफिशिएंट इलेक्ट्रॉन टू कंप्लीट इट्स ऑक्टेट. व्हाई? बिकॉज दे हैव ओनली 6 इलेक्ट्रॉन एंड ड्यू टू दिस दे रिक्वायर 2 इलेक्ट्रॉन फ्रॉम एनी अदर एटम टू कंप्लीट इट्स ऑक्टेट. दैट्स व्हाई दे आर इलेक्ट्रॉन डेफिशिएंट स्पीशीज एंड दे बिहेव्स एज अ लेवाइस एसिड. एग्जांपल याद रखिएगा. Last point, electron negativity. Down to the group, electron negativity first decreases from this B to Al and then increases marginally. This is because of discrepancy of this atomic size of element. अब ये discrepancies क्यों आई? Just because once again interventions of D block and F block elements. So the down to the group electron negativity first decreases B to Al and then increases marginally just because interventions of D and F block elements. So next we moved on to this physical properties. So physical properties. Boron is non-metallic in nature. It is extremely hard and black colored in solid. It exists in a many allotropic form. Due to the very strong crystalline lattice, बोरोन has unusually high melting point. नेक्स्ट सेशन के अंदर हम डिस्कस करेंगे एनोमलस बिहेवियर, उसके अंदर भी ये डिस्कस करेंगे. रेस्ट ऑफ दिस मेंबर आर सॉफ्ट मेटल्स with low melting point and high electrical conductivity. It is worthwhile to note that gallium with unusual low melting point, that is 303 Kelvin, could exist in a liquid state during the summer. Its high boiling point, approximately 2676 Kelvin, makes it useful material for the measuring high temperatures. Density of this element increases down to the group from boron to thallium. So this is all about your physical properties. So in this session हमने discussion किया introduction to this chapter, introduction to this group, and then few basic properties and physical properties of group number 13. Next session में हम discussion करेंगे chemical properties of group 13 and most important two part, anomalous behavior and diagonal relationship. This is all about your first session. Thank you.